Hey guys, today we're going to look at similar polygons, which is the next section in our similarity chapter. Similar polygons are polygons with the same shape but different size. So as you look at the triangles in this box, you can see that they're both triangles. They both look alike, but one is smaller than the other. Polygons are similar if corresponding angles are congruent and corresponding sides are proportional. The ratio of corresponding sides is called the scale factor. And if polygons are similar, their perimeters are also proportional. So we're looking at scale factor, and order does matter. So it's important that you look from small to big or big to small and keep it that way. What is the scale factor of triangle ABC to DEF? So you're looking for a couple of different things. A has 1 mark, B has 2 marks. So we're going to focus on this side 8. And D has 1 mark and E has 2 marks. So we're going to focus on this side 12. And we're going to reduce 8 over 12 to get a scale factor of 2/3. Now, if you go the other way, because you're going from small to big, you should expect the numerator to be smaller than the denominator. If you go from big to small, it reverses. So what is the scale factor of DEF to ABC? Then you would look at 12 over 8 and get 3 over 2. What is the ratio of the perimeter of DEF to ABC? So the perimeter, because the scale factor is the same from DEF to ABC, then the perimeter will also be the same. Congruence and similarity are different. Congruence means exactly the same. Similar means just what it says, they're similar. So the symbol for similar is just that wavy part that's on the top of the congruence symbol. A valid similarity statement must match corresponding angles and sides. Write a similarity statement for the triangles above. So I'm going 1, 2, 3, 1, 2, 3. So triangle ABC is similar to triangle DEF. When you have similarity, your angles are congruent and your sides are in proportion. So J, P, K, and M, L, and N would be your angles, and they are congruent. So angle J is congruent to angle P, angle K is congruent to angle M, angle L is congruent to angle N. That has not changed. But your proportional sides, instead of saying this side is congruent to this side, you set them all in proportion. So JK over PM, those are your first 2 letters, is equal to JL, first and last, over PN is equal to KL, last 2, over MN. Similar triangles can also be inside of each other. So if you look at triangle XYZ and triangle RYS, here is triangle RYS, and here is triangle XYZ. So you can see that one is inside of the other. Same thing. Angle X is congruent to angle R. Angle Y is congruent to angle Y. Angle Z is congruent to angle S. So angle Y is congruent to angle Y when we do proofs would be the reflexive property. And then your proportional sides, XY over RY is equal to XZ over RS is equal to YZ over YS. Using similar figures to solve for missing measures. If the figures below are similar with a scale factor of 2 to 3, find the value of X. So you set your scale factor up. Notice small is on top, so small stays on top. Set up a proportion, cross multiply, and solve. So 2X is 126 and X is 63. Number 6, if triangle ABC is similar to triangle DEF, find the value of X. You have to find the scale factor first, and you just set it up as big over small or small over big. You decide, but keep it consistent. So AB is similar to DE. So X over 25 is equal to BC 28 over EF 20. Cross multiply, and X is 35. Problem number 8 is done the same way. So GM and XD are going to be one ratio. And then AG and KX will be the other. So 36 times X plus 3 is equal to 32 times X plus 6. 36X plus 108 equals 32X plus 192. 4X is 84. So X is 21. Taking a look at your next page, more practice with similar figures. You're solving for 2 different variables here. So you have to use your similarity statement to determine how to set that up. So I'm going to do big to small. So JK and NM, 40 over 16, is equal to KL and ML, X over 14. And cross multiply, and X is 35. All right. And then I'm going to keep 40 over 16 because that is consistent. This time I'm going to do 45 over Y, 5 over Y, cross multiply, and Y is 18. Problem number 3. RS and UV, so 54 over 36 is equal to RQ would be 24 over X plus 5. And I'm going to reduce this to 3 over 2. So 3 over 2 is equal to 24 over X plus 5. That makes my numbers much more manageable. So 3X plus 15 is 48. Subtract 15 and divide by 3, and X is 11. Always remember, take as many steps as you need to get your problem right. All right, PM and PQ. So 24 over 28 will reduce to 6 over 7. So 6 over 7 equals, and you don't have to do that, just might make it easier. So 6 over 7 is going to equal X plus 8 over 3X minus 9. So distribute 7X plus 56 equals 18X minus 54. 11X is 110, so X is 10. And remember, similar figures don't just have to be triangles. They can be quadrilaterals or anything else. Let's look at number 7. So number 7 is going to be LM is going to be equal to QR. So LM and QR. So 4X plus 4 over 48 is equal to KN first and last PS 60. 7X minus 9 over 60. 336X minus 432 equals 240X plus 240. 96X equals 672. So X is equal to 7. Problem number 9, DE and GE. So 6X plus 3 over 17 is equal to 8X minus 1 over 21. 136X minus 17 is equal to 126X plus 63. 10X is 80, so X is equal to 8. Don't forget your questions box. Don't forget when you set up your proportions to keep it consistent. Either go big to small or small to big, and make sure you're doing that for both of your ratios. Let me know if you have any questions, and you guys have a great day.